first lesson in this unit is a quick review on ratios and proportions. A ratio is a comparison between two numbers measured in the same units. An example of this idea is in a two-stroke engine, you need gas and oil, like for lawnmowers or chainsaws or things like that. So, certain motorbikes, you need a mixture of gas and oil. And you'll be told how much gas and how much oil you need. So here's an example of a scenario like that, where you need 15 liters of gas for every 1 liter of oil. And if we were going to write that as a ratio, the ratio of gas to oil is 15 to 1, or also noted 15 ... to 1. And again, notice the units are the same. A proportion is a statement of equality between two ratios. So with my example above, if we had an engine twice the size of the example above, so in an engine twice the size of the above example, well, instead of 15 liters of gas to 1, we would have 30 liters of gas to 2 liters of oil. So these are examples of ratios and proportions, and these are the kind of things we're going to have to be able to do in the unit as we move forward. So here's a quick example of determining the ratio. The first part is, what is the ratio of corn to kidney beans? And again, notice that the units are all the same, so that fits our definition. So what we would have is 15 ounces of corn to 30 ounces of kidney beans. And this would be fine, except it's always a good idea to simplify if you can. And given that 15 goes into both of these numbers, we can simplify it down to 1 to 2. So what we might say is, for every ounce of corn, we need 2 ounces of kidney beans. Part B says, what is the ratio of tomatoes to kidney beans? And again, what we have is 36 ounces of tomatoes to 30 ounces of beans. And again, if we can simplify, it always makes our life a little bit easier. And the only number that goes into 56 and 30 is 2. So if we divide both sides by 2, we can make the numbers a little bit more manageable. Not really that much in this case, but it usually helps. So those are two examples of this idea of ratios. And here's this example of the power of a proportion. If things are bigger or smaller in proportion, then we can go ahead and solve problems. So for example, a big screen TV has an aspect ratio of 16 to 9, which means that for every 16 inches of width, there's 9 inches of height. And this is pretty much the standard aspect ratio for TVs nowadays. What is the height of a TV that has 48 inches of width? Now you could work your way through this without setting up a ratio, but we're going to set up our ratio, and then we're going to use that ratio to set up our proportion. So our ratio is going to be the width of the TV compared to its height. So we have our base ratio, are 16 to 9. And really what we want to know is if we have a 48-inch TV, what is the height? And in looking at this, um, it's set up technically as a proportion, but if you but there might be an easier way for us to work through it, and the easier way is to express this proportion as fractions. And when we do that, we're simply going to look at the width to height ratio in a different way. Instead of side by side, we're going to look at it top to bottom. And now we can go ahead and solve this equation. And we could solve this equation any way we want. We could clear the denominator, things that you learned in grade 9. But the easiest way to solve a proportion is to find a nice relationship across or up and down. And there is a nice relationship across. To go from 16 to 48, we simply multiply by 3. And again, you might have heard that thing called the golden rule. What you do to the top, you do to the bottom, and that's to maintain equality. And what you do to one, you do to the other, another golden rule. But in this case right here, 16 times 3 is equal to 48. And if we were going to maintain our equality, then we have to go 9 times 3 is 27. So in this example right here, we found a nice relationship, and we simply used it. Again, you could solve an equation, but this is just simply solving a proportion. Now, what I want you to notice is there's not a nice relationship going this way. 16 times something or 16 divided by something wouldn't be a nice number with 9. If that were 8, then we would have a nice relationship.